Hi, I'm Bob Allison with ShopSabre CNC. Around here they call me RouterBob. We got a real interesting video. One of the things I wanted to do was to show you some concepts for CNC to make fixturing or to do some complex setups. And the product that we actually selected is the neck for a mini banjo. So it's a very complicated part, and it requires machining from both sides. Now the concepts we're going to show in this actually apply to all the ShopSabre CNC routers. For this application, we're actually using a ShopSabre 23 because the part fits within the work envelope of that machine. Before we get started on the setup, let's take a closer look at that machine. You know, I think you'll find that the ShopSabre 23 leads the industry in this class machine. And there's a good reason for that. For one thing, the base frame is built just like our big machines. It's one piece, structural steel, all welded. The gantry is structural steel. You know, typically when in machines of this size, you find aluminum gantries and lightweight stuff, and the consequence is they just don't cut that well. You don't get the edge finish, you can't cut as fast, and so that's a consequence of that. Now, we take that frame and then we also use precision ball screws, and that gives you much more accuracy also. And we actually control this entire system with a new state-of-the-art ShopSabre control that we just developed. So it's a really, really nice package. Now, let's focus now on the application, and let's take a look at what I have set up so far. Okay, now if you notice on this table, first off, I've got a setup started here, but I want to point something out. This machine actually has a T-slot feature. Here's what you use it for. If you know, this is a fixture board, and we'll learn more about that in a minute. But basically what we've done is taken bolts in here and tighten those down, so that secures it. Then I've cut some notches in here because I want to use some clamps in one of the steps that we're going to do. So that's one of the reasons that you get the T-slot option. You can do stuff like this. Now another feature I really like about this machine is the router motor. We offer this machine with a 3 1/4 horsepower Porter cable router motor. And you say, well, why do you do that? Because it makes the machine run on 110. So with that spindle option, I can run this on 110. We also offer electro spindles of different sizes if you prefer that. Now, you know, a part like a banjo neck is a pretty complex 3D part. So we're going to use Rhino and Rhino Cam from Mexoff to actually do the tool pathing. Now let's go up and let's look at that part of this process next. I chose this demonstration because it has a lot of application stuff. It's, you know, we're machining on both sides of a part, it's fixturing on the machine, and it's flipping the part. So I wanted to do a video that shows you how to do all that. Think about this as a make it video, how you make something. Okay, so when we walk by the machine, you actually saw that fixture board. That's already put on the machine. We'll talk about that in a second. First, let's look at what we're actually making. This happens to be a mini banjo neck. And you can see it. So there's the solid model of it. So hopefully when we get finished, we're going to have some rough proximity of that. All right, but now let's walk through this step by step from the very beginning of how you set the machine up to actually position the part to do the machining. Okay, let's look at this concept of a fixture board, because we have to have a way to hold parts and position them so that we know where the machining is going to happen, and when we flip it, we want the front to align to the back. So it takes a bit of planning. So what you saw on the machine was a fixture board. At this point, if you notice these 4 holes, one in each corner, those correspond to T-slots in a table. So that gives us the ability to bolt that down to the table pretty well. Then I've got a notch here and a notch here. And the reason I've done that is because actually, when we put those parts on, in fact, we can probably see it like that. Let's turn that blank off. Now, if you'll notice right here, this plug sticking out, we're actually going to use a clamp that mounts through here to the T-slot down the center of this. So that helps us, and the reason we do that is because when you get to the back side, the surface area that's left isn't very much. So I'm worried about the part moving with just tape by itself, so I put those pieces on the ends to help to give us some room to clamp to. All right, so that basically that's how that's set up. That's why those holes are there. Now what we haven't done so far is we haven't actually done that machining, and that's what these grooves are. You can see a little bit better that way. That's what these grooves are. So these are basically just grooves to tell us for the first piece where to tape it on the table. And then we have these pockets here that help us prop it, get a screwdriver underneath it and pop it loose. And then the other thing is we have these pins. So once again, this is where we machine the holes for the pins. Now let's look at those actual tool paths. Here's the first one. You can see where the cutter's going to go around. There's the tool path for the pocketing, and there's the tool path for the drilling. So once we get that done, the preliminary setup work's done, then we start focusing on how we turn the blank into the neck. All right, our fixture board's set up, everything's in place. Now we take the blank and we actually attach it to the fixture board with double stick tape. And you can see on here, there's the blank. If we look at the end, you'll see how the parts are actually resting inside. It's actually centered within that blank. If we go back to a perspective view and look at the X-ray or ghosted version, you'll see there's the part that's down actually inside that. So what we have to do is remove all the wood that's not part of the blank. All right, so let's talk about what we do first. So primarily what I want to do is I want to face this off so that we basically remove the material from here to here. And the reason I'm doing that, and let's turn that blank off. The reason I'm doing that is because if you notice, let's render that, you can see it a little bit better. If you notice, this is flat across here, across this whole, this is the surface where the fretboard mounts. That's flat, and I'm also going to flatten the plugs on here that I put on for attachment. So the first thing I want to do is a facing operation, which basically brings the thickness down a certain amount. So that's what the first tool path will do, and let's see if we can take a look at that. Let's go back to ghosted. Now, so the first tool path is actually going to look like this. It's going to go back and forth, and once it's finished, there'll be a flat plane that's the top of it. So that's the first thing to do. Okay, now there's not that much 3D stuff that's on this particular part. Let's look up here. But there is up here where the keys go, there is an area. If we look right in here, this is machined down. So what we're going to do is we're going to identify this area, and we're first going to make a rough pass. And a rough pass simply just takes the material out. You know, it's not designed to make a smooth surface, it's just designed to remove material. Then we come back with a smooth finish. That's what produces a smooth finish right there. So that's what we're going to start with, all right? Now there's a couple more operations. Of course, we don't want to forget we need to drill our pinholes here, because when we flip it over, that's what's going to line it for the back side operations. And let's see, we've got that down here. Then there's two more operations. There's actually what I've done here, if you notice, these are counterboard. But what I'm going to do on this side is machine these through first, because when we flip it over, this is actually suspended in the air a little bit. And when we get to the other side, we have to machine the counterboards. But most of the drilling will have been done in this operation, so that's what we did there. Okay, then we've got the grooves for the rods. So there's actually one that goes all the way down, and then there's one down here at the end that makes it a little bit deeper. Okay, so once we've got those operations completed, that side, or the fretboard side, is completed. All right, now let's look at where we go from here. Okay, now let's take a look at what happens next. Okay, we've machined what I call the fret side. All right, now we turn that over and we put it on the table, and you can see the pins here. So we're actually holding that down with double stick tape, and then we're using pins here to get our alignment. And then if you remember, we're also clamping both ends, because that surface area on that fret area is pretty small, and we don't want it to move while we're machining it. All right, now one of the things that I'm just showing you pretty much the graphics on the screen here. The software I'm actually using to do all this tool pathing is called CAM, and it runs in Rhino. So Rhino allows you to create the 3D model, and CAM runs inside and allows you to tool path it. I'm not showing the entire screen so that you can see the graphic better now. Okay, let's look at this now in a perspective, and you see we'll get rid of that right there, because technically that's not there now. That's what it looks like. If we look at it rendered, there's what we got. All right, and we'll turn that blank off. So our part's laying on the table. Okay, so that's pretty much what it looks like. Now let's go through the actual machining operations, the tool pathing operations, and the procedure step by step of what we're going to do. Well, the first thing I'm going to do is actually a roughing, and that's what this is. So these areas here along this contour in the neck are actually, there's quite a bit of material there, so these are just roughing passes. Now a roughing pass, typically I'm going to probably use the same tool. It's a 1/4 inch ball nose, but the step over per pass is about 50%, so it gets rid of material, but it doesn't leave a finished surface. All right, once we've got that done, we're going to use a horizontal finishing pass, and that's going to do some of this. And then we're also going to do a parallel finishing pass. And between the two, we're going to get a really, really good definition of that surface. So that takes care of those. So these contours are going to be machined at this stage. Now, on something else I decided to do is, even though I think in this particular model these are flat planes, they are always not. So what I decided to do is treat those as a 3D surface rather than as a flat plane. So I went ahead and treated those as a 3D surface. In practice, you may not have to. Okay, then we've got our holes. So once again, if you recall, let's zoom into that a little bit. If you recall, we had already machined the holes from the back side, but if you look down in there, they're actually, you see those ledges? Those are actually, these are counter bores. So from the other side, we machined through, and then we'll just machine the counter bores here. So that's looking pretty good. And then the last thing we're going to do is we're going to go around the whole, everything. So what we're doing is we're basically taking a half-inch bit to go around there and get a nice edge on it. Now, there's something interesting, and let me show you. Let me see if I can figure out how to show you this. Let's go to Ghost View. See what I really wanted to do. Let's zoom in. Zoom into here. I really wanted to keep this attached. So if I hide, whoops, if we hide, let's just hide the plugs. We hide the plugs here. Now, you see how this comes up here? That's actually called a tab. So what's going to happen is the toolpath is going up, and it's going to leave this connected to that block. I'm not so much worried about this end as I am this one here. You see, because this is actually, there's some material here, it's probably a 1/4 inch up in the air. And so this toolpath comes up and bridges over that. So that leaves that connected to those plugs with just a little bit of material. That way it's not going to move. Now, you might actually make a tool path and cut through those plugs and take the chance of it moving. If it looks like the tape's going to hold good, you might do that. Otherwise, I would just cut those tabs through, and I've got them pretty thin, so I wanted enough material there to hold it to keep that rigid. But that should help you keep that part down. So hopefully, once we get this finished, we have a completely tool path neck. So I think what we'll do now is we'll create the programs. Let's go out to the machine, and now let's go through step by step on the machine what we just did on the computer, and let's see how our neck comes out. Okay, now this is the fixture board that we looked at in the software. We've got it secured to the table. So the first operation we're going to do is to cut those setup lines. So remember, we cut some shallow grooves around where each of the parts go. We're going to use a 1/4 inch down shear bit so that it doesn't chip the surface here. We're also going to cut some little pocket recesses to make it easier to get up. And of course, we have to cut our 2 holes for the pins that we're going to use later when we flip it over. So now let's go to the next step, and let's actually cut those on the machine. Okay, this came out really good. It looks exactly like it did on our drawing. Now the next step is to actually attach the material that we're going to make the neck out of. I'm going to use some double stick tape, and we'll just tape that down. All right. Now we'll see if we can get these out. Okay, now we've got our double stick tape applied and the backing peeled off. Now we'll just take our material, we'll lay it on there. Now, this is where the actual cutout that we made, it shows me where to position it, get it lined up good. All right, that's great. Now our next step is we're gonna put a bit in, and we're gonna fly cut this down so that this is the correct thickness, and then we'll do a couple more details on it. All right, let's do that. Okay, this came out really good. You know, our first goal was to face this and create a flat surface. Now, some of these are actually finished surfaces in the final product, so that came out real nice. Now, we've got a couple more operations to do. The next thing we're going to do is the 3D stuff down here. So I'll change tools and we'll machine that. All right, this came out really nice. It's real smooth. That's actually the only 3D surface on this side of the product. We've got a couple more operations to do. It's going to require a straight bit. What I'll do is I'll put the straight bit in. I'll use an automatic tool touch off to touch the tool off, and then we'll do the final machining on this side of the neck. It should come out good. Okay, this completes all the machining from this direction on the neck. It came out really nice. This slot's really nice. Everything looks like what we wanted. Now, these are the holes for the pins, the metal pins like that. Now, what we're actually going to do is we're going to install them over here. We're going to use double stick tape here also, and because we have these ends sticking out, we're actually going to clamp the ends here. And the reason is when we actually get finished with this is fairly narrow in here, and there's not much surface to tape, so I want to make sure we don't take a chance of it moving. Okay, let me get this setup changed over here, and then we'll cut the other side. Okay, now we're ready. I wanted to show you this before we lock it in. Okay, these are the pins that we talked about. These are the holes that they match. I've got my tape down here. So what I'm going to do is get those lined up. All right. And okay, that's good. Now we're also going to add some clamps on both ends to hold that down. Once again, because once it's cut out, there's not that much surface area. We'll get that set up and then we'll start machining. Oh, this came out really nice. Now we've got all of our 3D surfacings done here. I have 2 more steps. One is I have to machine the counter bores in those holes, and then we do a final perimeter cut. This is really coming on nicely. Okay, let me change tools. We'll do the next operation, and then I'll get back to you. Well, our counter bores look real good, and it looks like they're concentric with the holes from the other side, so I think our alignment system really worked. We've got one final operation on this, and that's to actually do a perimeter cut. So I've got a router bit in there. We're going to do that, and then we'll take this off the machine and look at it real closely. All right, that was our last tool path. Everything looks really, really good. So now we've got our tabs that still connect to these blocks, so we'll go cut through those, and we'll get this part out and look a little bit closer. It looks like it came out really, really well. Boy, this really looks nice. You know, it's amazing. That was hiding in that block of wood all the time. You know, what amazes me also is the edge finishes and the accuracy we got on that. It's what I would expect probably out of a Pro Series or an IS Series. But I think you can attribute that to our frame design on the ShopSabre 23. You know, we use the same design principles and engineering that we use on the larger machines, and we use steel gantries and steel frames. So, you know, it's pretty rigid, just like the larger machines. Now, I hope you enjoy this. I wanted to show you some techniques that you can use to, when you have a complex part like this, where it has to be turned over and the back has to line up with the front. Remember that the techniques we used also apply to larger machines and larger parts. Well, I hope you liked the video. We had a great time. There's something about woodworking that's therapeutic, and I think when you make things like this, you really experience that. If you need any information, you can contact us at www.shopsabre.com. Thank you for watching.